Hi. Today I wanted to go through some of the code that I've got. It's most of it is from this tutorial here. He's on YouTube. He's got this really great tutorial. I recommend you to check it out if you're into Raspberry Pi 4 and bare metal programming. He's actually making a game in this one. It's a simple game, but still it's actually a complete game, which is cool. And he shows you exactly how to do it. He's showing you how to do Bluetooth and everything. So go in there. That's what I did. I'll also leave a link in the description, of course, and sometimes I'll jump in here and check some of the things, that he's got. So yeah, check that out. There's a link below. I just thought I'd explain briefly some stuff in this code. And one of the difficult things that I found was this 16-byte aligned, and why that makes the 4 least significant bits in a 32-bit value, why it makes them zeroed out. Yeah, because to me that didn't make sense. So I went to Wikipedia, of course. And as it says, a memory address A is said to be n-byte aligned when A is a multiple of n bytes, where n is a power of 2. Although I understand all these words individually, I just didn't get it. But I continued reading, and then I found this, and this is the way to actually calculate how many least significant bits there are in an n-byte aligned address. And we got 16-byte aligned address, and that will give us 4 least significant bits. So I'm content with that. If someone has a good explanation to why it's called byte alignment, drop me a comment or something. But for now we're just gonna move on. So I've cheated a little bit. I've started renaming stuff. Well, you can't see it actually. It used to be another name. Well. So what is this? What's going on here? What am I doing here? So I got this array, okay? It's an unsigned int array. It's volatile, means everybody can touch it. And to call the video core with this mailbox system, you need to have a 28-bit address, and the last 4 bits will be used as an argument and will determine what channel you wish to use. Okay, let me show you the channels. These are the channels. We will use this prop, number 8, and this is when the ARM requests a response from the video core. Simple as that. So you pass in number 8 in this function. You have this int, which you define as taking you take the address of this mailbox that I've got here, the 16-byte aligned one, and you convert it into an unsigned int instead of a pointer type. And in this case you have to clear it manually, right? So this is you masking the least 4 significant bits with this one here, but you do it with a not. So that means that you're masking it with 0, which means you will clear the last bits out, and then you'll add and make sure by masking with the least 4 significant bits this byte value and you append it into the int here. So now you have exactly what you need, which is a 28-bit address with most significant bits and a 4-bit value of least significant bits. And like this comment says, we will call this function here, which will read the address that you put in here and return the value which is stored in this address. And then this value we will mask with the mailbox full value here. And while this is full, you will just keep reading and reading. This is a typo, and whenever this is done, when this is no longer the case, we will move on and we will write this address here. Let me see exactly what happens here. Let us see this. Can we see this? Here we go. When you write, you put in the address as the first argument, and then you put in the value as the second argument, and then you take this address and you dereference it, and you add the value, and then you write the value to it. It's as simple as that, actually. Back here, so this is the value that you write to this memory address. Yeah. And then you just wait. Again, if there's in status there should be something that is not mailbox empty, which is this. And whenever that's the case, you go on and then you look. This, remember, this is the address, the 28-bit address and the 4-bit value of your mailbox. And if this is the same value when you read the mailbox read address, this one, you'll have a reply to your specific request. And then we return whether this worked or not, so that we can handle failures, basically. I guess that's it. I used to initialize the frame buffer. This is the way to do it, basically. So you need the length of the message. You need the mailbox request. Move this one here, which is just 0. Let's see if we can see these. Yeah, here we go. Here are some values. You can look at them later, or pause, whatever, or just go to the tutorial I just showed you. Okay, and then you set some values here. The byte values, the width and the height. Again, not here. Oh yeah, this is some offset. I guess you can use it to make screens, or like windows or something, I guess. And here's how you set the pixels, size in bytes, and how many bits is that? That's 2 bits, because you want the alpha channel as well. And this is the byte order. I guess you could have the other way around, like be a GR or something. And here's the actual frame buffer. I don't know exactly where you write this value here. Doesn't matter too much. We'll learn as we go. Yeah, and then you call here, see, this is the value 8, and then we check to see if it's a 32-bit value for the pixels, and then to see if the actual pointer is not null. Then this is one of the important things here. You remember we did all that thing with the 16-byte alignment stuff. Yeah, now you're gonna need to convert it back to addresses that are valid for the CPU, so that you can actually use this pointer. Yeah, and I set some variables here: width, height, pitch, RGB, buffer size. Yeah, that's it. Well, that's not entirely it, but this is one way to get a frame buffer. You're using the mailbox. Oh, well, I guess this is pretty much how you get it. You can do some configurations in this request here, of course, but this is how you do it. You use the mailbox.